So in this lesson, we're going to compare what a linear equation looks like versus what a quadratic relation looks like. So if we just take a look at the actual equations, the equations look very similar. They both have 6x, 3y, and 9, and they're both set equal to 0. So this is standard form, and this is also standard form. But one big difference is that this has a term that's squared, and this term here is not squared. So the result of the squared value is this U shape, which is called a parabola. That is a significant difference from if you look at just a linear relation, which is a straight line. Some things to notice about this graph. So this is curved, obviously, and this is not. They both have the same y-intercept, but this is a straight line. Again, it has an x-intercept. This does not have any x-intercepts. Okay, so even though the equations are almost identical, the presence of this squared term completely changes the characteristics of the graph and turns it from a straight line into a curved line called a parabola. So to figure out what the degree of a polynomial is just by looking at the equation, we have to look at the highest exponent of its variable terms with non-zero coefficients. All that means is that you're looking at the terms there, so the variables, and the number in front of the variable has to be a number. It can't be 0. If you look at any of these examples, none of these have a coefficient of 0, so we're just looking at which one has the greatest exponent, and that is the degree of the equation. So if we look at this one, this is in standard form, so we have x and y, and the greatest degree of x and y is both 1, so that means that this is a linear relation. If we look at the second one, we have y that has a degree of 1, but then if we look at the x's, there's two x values. One has a degree of 2 and one has a degree of 1. So the highest degree is 2, so that means a degree of 2, and therefore it is quadratic. So if you take a look at this third one here, the brackets are touching, which means they're multiplying. So even though inside the bracket it's a degree of 1, because they're touching, that means multiplication, and therefore if you were to do FOIL, the first two terms would multiply to be x squared, and then you'd have your other terms, so that means this is a degree of 2 and is therefore quadratic. Okay, so taking a look at this equation, the first term has x squared, but if we look at the next term, it has a degree of 3. And so when we're finding the degree of the polynomial, it's always the greatest degree or the highest degree, so that would be 3. And so this is not quadratic, but instead it is called a cubic function, so it has a different shape. So taking a look at the next one, we have 3x plus 2 squared. So even though something's being squared, it's a number that's being squared, not a variable. So the highest degree on the variable is still 1. So if I simplify this, it's going to become 3x plus 4. So the degree is still 1, and therefore it is linear. The degree of 2 has to be on a variable, not on a constant term, so not just on a number. So this last one, again, inside the bracket, it has a degree of 1, but we have to remember, what does x minus 1 all squared mean? It means x minus 1 times x minus 1. So if I distribute this, because these are being multiplied, if I do FOIL, then I'm going to get an x squared term. And so this is a degree of 2 and is therefore quadratic. So the reason why we want to be able to differentiate between a linear equation and a quadratic equation or something else is because every type of function has its own set of characteristics. So a linear equation, a degree of 1, has predictable characteristics. It's going to be a straight line. It will have a slope. It will have a y-intercept. All things that we can predict and model. Quadratic equations, the same thing. They all have key features, and that's what we're learning about. How can we use this new equation and the strategies that we've learned about factoring and finding the x-intercepts to figure out those key features? So when we're talking about different functions or different graphs, different equations, there's 4 ways that you can represent any graph or any equation. One is by using its equation. One is by the table of values. One is a description in a word problem, so using words, and the other is by its graph. So we already talked about how to figure out whether it is quadratic based on the equation, so now we'll see, well, how can we, and by its graph, how can we figure out now looking at the table of values whether something is linear or not? Okay, so you can pause the video now and fill in the table of values, and then we will discuss. All right, so when filling in the numbers, you literally just have to plug in the x value and then calculate. So -2 times 2 is -4, minus 3 is -7, and then you would just keep going from there. You do the same exact thing for the quadratic as well. You just plug in the value and calculate. All right, so now we filled in our values, and now what we're going to do is we're going to find the first differences. So to find first differences, we are going to look at our y values, and we're going to subtract. The way that you subtract, or an easy way to always remember, is to start from the bottom and subtract the bottom number from the previous number. So 1 minus -1 is 2, -1 minus -3 is 2, -3 minus -5 is 2, and -5 minus -7 is also 2. So we can see that the first differences are constant. First differences are constant. And we know linear functions have a degree of 1. So degree of 1 and the first differences are constant. So let's see what happens when we look at our quadratic function. So if we do the same thing, the first differences, 7 minus 0 is 7, 0 minus -3 is 3, -3 minus -2 is -1, and -2 minus 3 is -5. So we can see that the first differences are not constant. So we know from our previous knowledge of linear relations that if the degree is 1, which means you have a linear relation, which means you have a straight line, your first differences on the table of values should be constant. It should be the same number. So like the spacing between the y values should be exactly the same. If we look at our quadratic function, we can see that the first differences are not the same. So we can conclude that this is definitely not a linear relation. So first differences are not constant, therefore non-linear. So we know that it's definitely not a straight line. Okay, so let's try the second differences now. Second differences is almost exactly the same as the first differences, the same process, it's just now you're subtracting the first differences numbers. So 7 minus 1 is 4, 3 minus -1 is 4, and -1 minus -5 is also 4. So we can see that our degree is 2 and our second differences are the same. So what we can conclude then are that quadratic equations have constant second differences. Okay, so we can tell that it's quadratic by looking at the equation. It has a squared term. How can we tell? By looking at the table of values. We fill in the table of values, and when we take the second differences, so we do the first differences, they should be different because it's not a straight line, and then we do the second differences should be constant. That's how we can tell it's quadratic. If they were not constant, if they were a different amount again, so different numbers again, then we would say that it is neither linear nor quadratic. It must be something else. Okay, but for a quadratic function, the constant, you must have constant second differences. So degree of 2, second differences are constant. Degree of 1, so linear, first differences are constant. So in summary, the graph of a linear relation is a straight line. And the graph of a quadratic relation is a curved line that has a special name. It's called a parabola. The equation of a linear relation has a degree of 1. So for example, y equals x. A quadratic relation has a degree of 2. So that's y equals x squared. Or something, it has to be x squared. And then the table of values of linear relations, first differences are constant, which just means they're the same. For a quadratic relation, second differences are constant. These key features are very important for you to identify if you have a quadratic relation. How can you tell you have a quadratic relation given these different pieces of information, either an equation, a graph, or the table of values?